So this is lesson, what is it, 4.5. And what I want to do is I want to be able to compare arithmetic, aka linear, and geometric, which is aka exponential. Okay. When we look at the second problem on our quiz, it looks something like this. We're given our x, we're given our y. We've got 1, 2, 3, 4, 5. Our first term we're told is 2, and our last term is 162. And I asked you guys to find the missing values there. Okay? I asked you guys to find those missing values. And so when you find those missing values, the problem itself asks for you to do it geometrically. And so the way that we've been doing this is we've been looking at this geometric. I know that 2 times some sort of common ratio, 1, 2, 3, 4 times r to the 4th power is going to equal 162. By deriving this equation, I can figure out what my ratio is. R to the 4th is going to equal 81. R is going to equal the 4th root of 81, which ends up being 3. So I know that my ratio is 3. That means I'm multiplying by 3 each step. So when I multiply by 3 each step, 2 times 3 is 6, times 3 is 18, times 3 is 54. Is that right? 54. 54 times 3 is 162. Okay. And so I'm able to construct that by figuring out that ratio. And in fact, if I were to graph this, which I will right now, let's look to see what it looks like. If I were to graph this, so I have 1, 2, 3, 4, 5. One thing I want to draw your attention to is the idea of scale. Yeah, Tessa? Think about the guy, better get a room, better take care of me. 2 to the... Think about this 2 to the 4th power. I'll have to look at it later just to double check it. Okay. When we're looking at this, and I'm asking you to graph this, clearly we do not have room to make 162 hash marks, so we have to do something called scaling, okay? We have to scale what each of these lines will be. And if I have to get all the way up here to be 162, that means each of these lines need to count for more than 1. I'm just going to guess that an appropriate scale would be about 10. So if this were to be 10, 20, 30, I'm still going to be a little bit short, but it'll be enough for me to at least have a general idea. Now I'm going to plot my points. I know that the point 1, 2 is a point. That's going to be right there. I recommend doing this in your notes so it's clear. 2, 6. 3, 18. That's going to be almost 20. 454, and 562 is going to be somewhere way up here. And you can see when I do this, what I end up with is I end up with a curved graph. I end up with a line that shoots upwards like that. Easy enough. The moon flows onto the But let's assume now, does everyone have this in their notes? I don't want to move ahead until we're set to go. Give me a thumbs up if you're in. Give me a thumbs up. A little bit more time.
I'm looking at the future, solid as a rock because of you. Wanna be here and I wanna be there, living just like you, living just like me. Forever. Putting on my gloves and I bury my bones in the marshland. Forever. Think about my soul, but I don't need a thing. It's the ring of the bell and the pure clean air.
This time, what I want to do is, let's say I was given this exact same coordinates, these exact same lines here as I was given up here, but this time instead of being asked to find a geometric pattern, I want to find the arithmetic pattern. If this was my start point, that was my end point, what does that look like for an arithmetic function? Okay, let's give that a try. This time what's happening is I'm adding by a certain amount. Right? This time instead of multiplying, I'm adding. But one of the easiest things about this is we can do this just as a slope formula, right? Because I can do my change in y over my change in x and figure out my slope. So to do that, I have my y2, which is 162, subtract my y1, which is 2, and then I take my x2, which is 5, subtract my x1, which is 1. So I end up with 160 over 4. 160 divided by 4 is 40. And so what that tells me is my common difference is 40. I'm going to add 40 each time. So this becomes 42, 82, 122, and then 162 when I add 40 each time. Okay. So let's see what this looks like. Well, I know that my first point and my last point are going to be the same because those are both already defined. Those are given to me. But let's see how it changes otherwise. Here at 2, I'm at 42. So that's something like right there. 3 is 82, which is something like right there. And then 122, which I'm guessing would be something like that. And then it connects. So I end up with, instead of a curve, instead of a curve, I end up with a straight line. Does that make sense? So when we're talking about the difference between geometric and arithmetic, we end up with these two vastly different visual representations. The purple is this curved line that slopes upward, starts out kind of slow, and then very quickly rises up. The red line is our linear, just a straight line going from point A to point B. What I'm going to ask you guys to do in the homework is exactly this. I'm going to give you a couple of different representations and ask you to find the difference, whether it's geometric or arithmetic, and compare them and see which ones are growing faster.